Good afternoon everyone and welcome to our webinar this afternoon. Today we'll be looking at lighting for railway crossings. Thank you all for taking the time to join us. This is our second webinar for the year, so we're gearing up for a very busy program ahead, and we hope that you can all join us next time as well. I'd like to introduce our presenter today. He is based in our Sydney office, of course, and his name is Ganesh. Ganesh is a senior research engineer, and as mentioned before, he's based in our Sydney office. We've got his contact details there in case anyone wishes to contact him afterwards. He's very open for you to do so. My name is Angela Juhas and I am your moderator for today. So if you have any general webinar related inquiries or anything to do with training here at ARB, you're most welcome to contact me at any time also. Before we commence our presentation today, I'm just going to go through a few housekeeping matters with you, and I see many of you are already regular webinar attendees, so I won't spend too much time. We're aiming for about 40 minutes today for the presentation, with about 20 minutes for question time. Please don't wait until the end to ask your questions. Obviously, the more interactive the webinar, the more enjoyable it will be for all of yourselves. We're also recording today's webinar session, and so anyone is welcome to view it again afterwards, and everyone will also be sent a PDF version of the materials, so don't worry too much about taking notes either. We ask that you communicate with Ganesh or myself by typing your questions into the question box in your control panel, and when we receive those at our end, we will stop at the allocated question time and Ganesh will answer those questions for you, and if of course he doesn't get to your questions today, you may also contact him after the webinar. Now, Ganesh might also ask you to raise your hand at some point, at which point we're talking about this little hand icon in your control panel, so it's just a matter of clicking that button if relevant. That's about all from me, and so I would like to introduce Ganesh and thank him for his time today. I know he's quite passionate and excited about this subject matter, so no doubt we've got a very exciting and interesting presentation to look forward to. So Ganesh, could you tell us today a little bit more about yourself and your work here at ARB?
Yes, good afternoon, Angela. Thanks for the introduction. Yeah, my name is Ganesh. I'm a senior research engineer here at ARB in the Sydney office. My role here is in the Safe System team. I'm one of the members in the team. My expertise and my interests are in mainly road safety, and for the past 2 years I've been doing quite a bit of work in the area of railway crossings, and this is how I got involved in this particular project. And it's I hope thanks for attending the webinar today, and I hope you find the information useful and be able to apply it to your future projects. Thanks, Angela.
No doubt they'll find it very interesting. So without further ado then, why don't we get started, Ganesh?
All right, thanks. Yes, for today's presentation, I'll just go through an outline of what we're going to cover, and I'll try to go through the webinar in about 40 minutes, and that will leave about 20 minutes for questions, but you don't need to wait till the end to ask any questions. If you think of something during the presentation, just send your questions through and Angela let them know. During the presentation, I've also slotted in some slides for questions, so we can take a break for a couple of minutes just to ask some questions. For today, first I'll start with the objectives of the presentation and what will be the learning outcomes, what you could take away from today's webinar. And I will define the key concepts for the lighting for railway crossings, what you need to look at, what you should concentrate on, what are the key terms that I'll be using over this webinar. I'll explain the design considerations, design criteria, design principles that you will use, that you should look at when designing lighting for railway crossings. And I'll also present a few different lighting layouts at railway crossings. What are the different layouts for lighting at different types of railway crossings and different types of layouts, approaches to railway crossings. And finally, I'll introduce the new RMS, the Roads Maritime Services New South Wales Lighting and Railway Crossing Guideline. This is a new guideline that was released probably the last quarter of last year in 2013, and it presents all the material that's going to be covered in this webinar. And ARB was involved in assisting the RMS in developing this guideline. And finally, I will summarize the key points from the presentation. Well, before we get into the presentation, I just want to have a quick poll question just to see, just to get your idea of what do you think, should lighting be implemented at railway crossing?
Alrighty, well you will all see a little pop-up box on your screen.
Lighting, yeah.
Sorry, all the audience will
Meeting
see a pop-up box on their screens, and it's just a matter of answering either A, B or C, whichever you think the correct answer is, and then we'll close off that poll. So the question is, where should lighting be implemented? And as I said, we'll leave that open for just another couple of seconds until we get everyone's votes in. And I can see that just about everyone has voted now, so I might just close that and share the results. So Ganesh, we have 89% of our respondents answered C, so both on approach to and at the crossing. So how do you feel about that answer?
That's excellent, actually. That's the correct answer.
Fabulous.
Yeah,
well,
when looking at lighting,
a very learned audience here with us today, so that's fabulous.
Yeah, great. Yeah, exactly. When looking at lighting, you should look at both the approach and at the crossing. I'll get into this more in detail during the webinar. And what are the objectives and learning outcomes? First, the objective of the webinar is looking at what lighting for railway crossing is all about. What is it about? Why do we need it? Why do we want to provide lighting at railway crossing? And where, which type of railway crossing, which type of road layout should be provided? And if you consider lighting at railway crossings, how are you going to go about doing it? What should you be using? And I will also introduce the new guideline that RMS have prepared to allow practitioners to implement lighting at railway crossings. From the webinar today, the expected learning outcomes will be for you to understand the key concepts and the design criteria of how you will go about designing and applying lighting at railway crossing from a road user perspective. You've got to understand that the lighting for railway crossing is primarily for the road user, for the driver, for any other road users that is going to be negotiating the railway crossing. It's not mainly for the train driver, it's mainly for the road user. So it's more for from a road safety perspective. So you could recognize that how lighting can help to improve road safety at railway crossings. So let's get into the overview. What is it, where, why, and how? So what is lighting at railway crossing? Lighting at railway crossing is defined as providing lighting on the approach to and at the crossing. You're going to look at two areas here. You're going to look at the approach to the railway crossing, and why do you need to do this is to help illuminate the road layout. For example, you might, especially in rural areas, you might have lots of winding roads. That's going to, the winding roads, it helps, the lighting helps to illuminate the road layout on approach to railway crossing. At night, a lot of these rural roads are not lit, so drivers may not appreciate the road alignment, and so as they approach the railway crossing, they may approach it at an inappropriate speed, or they may not realize that it's on a curve approach. They may lose control. So lighting helps to illuminate the road layout, gives drivers a chance to appreciate what the road layout is like on approach to a crossing. And then once you get to the crossing, you also have lighting at the crossing, and the aim of the lighting at the crossing is to illuminate the crossing itself, to allow drivers to identify where the crossing is, and secondly, to observe the presence of a train traveling across the crossing. And in some rural locations, you might have trains that are stopped for a period of time for shunting operations, where you might have freight trains. They may dismantle a few carriages, so they may stop at the crossing, and the lighting at the crossing gives drivers a chance to observe that train is stopped at the crossing. The lighting helps to illuminate the sides of a train. And why do we need to provide lighting? The main aim of providing lighting at railway crossings is, from a road safety perspective, is to reduce vehicle train crashes at night. It also includes near misses and helps to improve overall road safety from a road user perspective. And how do you go about doing it? How do you go about developing the criteria? How do you developing the designs and then going about applying it? You use the concepts that you're going to learn today in the webinar, and this will help you think about where you're going to implement lighting, on which sites, how you're going to select sites, how you're going to prioritize the sites, and once you've done that, how you're going to design them. So these are the things that what lighting at railway crossing involve. And before we get into the core element of the presentation of the webinar, I'd just like to quickly go through what are the two main types of railway crossings. The two main types in Australia are the active and passive. Active railway crossing, as you can see from the photo right here, it's a crossing that have physical controls like boom gates and lights to warn approaching motorists that a train is arriving at a crossing. When a train is approaching a crossing, it triggers a mechanism that triggers the boom gates and the lights, so a driver knows. But on a passive crossing, if you look at this photo here, there are no warning devices. They are just static signs. It could be a stop sign or a giveaway sign. And it's up to the responsibility of the driver approaching the crossing to stop, take a look, see if it's free, see if it's clear, there's any trains arriving at the crossing, and then proceed on. So these are the two main types of crossings in Australia, and these are the two types of crossings where we'll be looking at implementing lighting. Just look at the current scenario or in terms of railway, in terms of crashes at railway crossings. The latest data that we have that from this research that we did was in 2010, there were 100 crashes at railway crossings. Out of these 100 crashes, 46% of these crashes were attributed to road user errors. Road user errors could be speeding on approach to a crossing, not stopping in time, and crashing into the sides of a train, or failure to give way or stop to check for if the crossing is clear before carrying on. And on average, annually, in the last 10 years, there were about 2 crashes per year at railway crossings at night. This does not include near misses. There may be near misses at night, but they may not have been reported. So you might be, asking yourself, 2 crashes per year at railway crossings at night is probably low incidence, so it probably doesn't warrant any kind of treatment, especially lighting. But if you think about it more in detail, if you look at it from a bigger approach, a crash at a railway crossing has quite severe consequences. It might be low incidence, but the outcome could be severe in terms of injuries and impact costs or compensation costs, etc. What are the various risk categories that you have to look at railway crossings? On approach to crossing, you might have loss of control incidents. On approach to crossing, as I mentioned earlier, the approach could be straight, the approach could be a curved approach. At night, a driver may not appreciate the alignment of the road, may negotiate the road alignment at an inappropriate speed. So lighting will help illuminate the road layout and give drivers a chance to appreciate the road layout. At the crossing, what are the risks at the crossing? First, at night, it's dark, there's a risk of drivers failing to firstly notice the crossing. And if they fail to notice the crossing, they may not stop at the crossing. And also at night, it's very difficult to see a train at a crossing. All you could see is probably just a dark silhouette, which is going to be quite difficult at night, especially for a driver driving in a rural area where there is very, very little ambient light. So these are the risks. And the consequences is a high severity outcome for drivers and train occupants. If you look at the next slide, that would probably explain the consequences in detail. What are the impacts? Injuries. When a train collides into a side of, when a car, collides in the side of a train, chances are the passengers in the car, the drivers, are going to get injured, and the injuries will be severe and can also lead to fatal injuries. And not only the drivers and passengers in the car, the train, the occupants in the train driver, if it's a passenger train, there's a risk of the train derailing at the crossing, and that could cause further injuries and high severity outcomes to the train occupants. They're going to have damage to property, both the car and the trains. And after each crash at a railway crossing, the railway authority has to close the crossing before it can reopen, make sure everything's clear, all the debris is clear. If there's nobody injured, make sure everything is clear before they reopen the crossing. And there's delays. And when there's delays to a road user in terms of congestion, delays in terms of the train operator, in terms of delaying getting their goods or passengers to where they need to go. And these delays need to be compensated. So there's compensation costs, and the government may need to absorb this compensation cost and then pass it on to the train operator. So there's a huge impact at crashes at railway crossings. So if earlier slide, when I mentioned 2 crashes at night, which may be a very, very low incidence, but if you look on the overall big picture in terms of the impacts, you could understand why this is an issue that needs to be thought of at night. You might have 2 crashes, but what can we do to help reduce it? How can we do to help prevent it? And so lighting is an option that can be seen to help improve this situation at night at railway crossings. So I think that would be a good place to stop for questions if anybody has any questions or we have questions come through.
Actually, we have had a really great question from Rosie. Rosie is asking, are there any plans to increase the number of active crossings and therefore decrease the amount of passive crossings?
Yes. From our research in New South Wales, there is a policy that was released last year where all passive crossings will be converted to active crossings. So the number of passive crossings overall in the next few years will be decreased, and eventually there will no longer be any passive crossings. All passive crossings will be converted to active crossings with boom gates. And existing active crossings that only have lighting control will have boom gates installed. So it's a process that was implemented last year and will take probably the next few years for all railway crossings in New South Wales to become active crossings.
Well, that's really good to know for New South Wales.
Yes.
Is that, or do you think that's the case with the other Australian states as well?
Yes. Part of research, we know that other states have really implemented this, and New South Wales is slowly going that way, and eventually passive crossings will all be converted to active crossings in Australia.
All right, great. Well, we look forward to all those passive crossings being converted. In the photo that you showed, it certainly looks very, very unsafe and a little bit disconcerting actually, so it's good to know that we're fixing this issue. All right, well we might get back into the presentation then, Ganesh.
Right.
Thanks.
All right, thanks for the question. Right, we'll just move on to the next slide. So now I've just presented the background of lighting at railway crossing. Now we'll get into the more detailed element of it. So what is the objective of lighting at railway crossings? It's firstly from a road user perspective, it's mainly to improve road safety for all road users. Drivers, you might have cyclists, you might also have pedestrians negotiating the railway crossings. So lighting helps to improve road safety for all road users. And how does lighting achieve this? It improves road safety by firstly enhancing the visibility on approach to the crossing, and secondly improving the visibility of the crossing and the sides of the train. So when a driver approaches the crossing at night, the lighting will be able to illuminate the road layout. So if it's a curved approach, a driver will be able to see clearly the road layout. As he approaches the crossing, he'll clearly be able to see that it's a crossing in the road ahead. And if there's a train traveling across the crossing, he will be able to clearly see the sides of the train. That will give him greater opportunity to slow down on approach and stop to give way to the train. So this overall lighting the approach and the crossing helps to improve road safety at night at railway crossing. So the benefits are, as mentioned, it helps to enhance visibility at night. So if you have better visibility on approach at the crossing, you have better driver awareness, you have improved driver behavior. A lot of the research at railway crossings suggests that drivers tend to be a bit complacent at railway crossings, and the reason is because they feel that they travel along this route numerous times. It could be a route that they use to travel home, to travel work across this crossing, and 9 out of 10 times during the week they travel across this crossing, they don't see any train at all, especially at night. But that one-off chance where a train comes by and they try to beat the crossing and try to beat the train, and that's when incident occurs, and it could be high severity incident. So if a lighting improves the situation, if a lighting helps drivers be less complacent, be more compliant at railway crossings, they help to reduce the incidence of vehicle train crashes at night. So now we're going to look at the lighting requirements. How are we going to tackle the lighting requirements at passive and active crossings? There are two types of crossings, and the way you approach the lighting design, lighting application is a bit different. Firstly, let's look at the passive railway crossing. At the passive railway crossing, as I mentioned earlier, there are no controls. There's nothing to tell the driver that a train is approaching. It's up to the responsibility of the driver to either stop or give way, slow down, stop, look to make sure that the railway crossing is clear before carrying on. So at a lighting railway crossing, you want to ensure that the approach to the crossing, the road layout, is well lit, as well as the lighting at the crossing to help illuminate the crossing, help a driver approaching crossing to see where the crossing is located, and also identify a train if a train is at the crossing. At the active crossing, you will tackle it slightly different way, because at the active crossings you will have active measures at the crossing. When a train is approaching the crossing, these active measures are activated. Boom gates come down, flashing light starts flashing, you might have alarm bells. These help to let an approaching driver know that it's the crossing ahead and a train is arriving at the crossing. So for an active crossing, you will not necessarily look at lighting the crossing, you only look to light the approach to the crossing, to illuminate the approaches so that drivers have a better appreciation of the road layout. But you might also consider providing lighting at the crossing based on site conditions. You might think, okay, this crossing at night tends to be really dark, it will benefit from a bit of lighting, or there may be quite a number of near misses, so you might consider. So at a passive crossing, you look at providing lighting on the approach and at the crossing, and an active railway crossing, you look at providing only on the approaches, but you might provide it at the crossing based on site conditions. One key term that I would like you to keep note is the difference in color contrast between the lighting approach to and at the crossing. This is perhaps the most important point of the webinar. And the reason that's why I highlighted in red, because when it comes to lighting at railway crossings, we're looking at lighting approach and at the crossing. The contrast needs to be different. There needs to be a clear difference in color contrast between the approach and the crossing. The reason why is at night, if you look at lighting, if you light a road with the same level of lighting, a driver does not appreciate that there's something in the road ahead, doesn't realize there's a hazard in the road ahead, because he just gets into this tunnel vision and starts driving, and he just sees a row of lights. If there is a color difference between the approach lights and the lights at the crossing, as a driver driving down the road, he can clearly see, okay, on the road ahead, the lighting changes from maybe a white light to yellow light. There must be something going on there. There's probably a hazard, and that's the reason why a driver might start to be more aware of what's coming up. And that's why the difference in color contrast between the lighting and approach to at a crossing is perhaps the most important point of lighting at railway crossing. So next are the key concepts. There are four main concepts in lighting railway crossings. The first is vertical illumination and horizontal illumination, and then category PX and category V lighting. What do I mean by these? First, let's look at horizontal illumination. Horizontal illumination means lighting the horizontal plane. It's just normal, regular, standard road lighting that you see on the roads when you drive down the roads at night. The road lights, the street lights that illuminate the road layout, illuminate the curbs, allows the driver to see what the road layout is like, what is the road markings, and what is where the curbs located. That's horizontal illumination, and we call that horizontal lighting category V lighting in Australia. Category V lighting is used to light the road layout for horizontal illumination. In Australia, vertical illumination means lighting in the vertical plane, and it's mainly used at pedestrian crossings. And why vertical lighting? Because at pedestrian crossings, you want the lighting to be up to a level of 1.5 meters so that a driver can see a pedestrian crossing the road. And that particular type of lighting is described as category PX crossing, category PX lighting. And I'll mention where category PX and category V comes from in the next slide. And how is category PX vertical illumination applied at railway crossings? Because if you look at railway crossings, it is similar to a pedestrian crossing where it runs perpendicular to the road. And when a train goes across a crossing, you want the driver in a car approaching to be able to see the sides of a train. And so vertical illumination illuminates up to a height of 1.5 meters. So probably the sides of the train up slightly higher than the rails. That's where the lighting the extent of the vertical illumination. So a driver approaching the crossing will be able to see the sides of the train. So these are the four main terms at lighting at railway crossings. It's horizontal illumination, and category V lighting is used for horizontal illumination, and vertical illumination, lighting the vertical plane up to a height of 1.5 meters, and we use category PX lighting. And these terms come from the Australian standard. When we were doing research for this project, we didn't want to come up with new terms. We didn't want to come up with new concepts. We wanted to use what is already there, what's already what the practitioners are familiar with, the terms practitioners are familiar with. So we looked at AS1158, which is the lighting for roads and public spaces in Australia. We used the information in the AS158. It contains 8 different parts, and it's quite detailed in terms of different types of lighting, the lighting requirements, the illumination levels, and we use that to provide technical input into this research. And from this technical input, we developed the design criteria for the lighting railway crossings. And from there, we picked up the 2 category V and category PX lighting. So category V lighting is lighting for road spaces. it's lighting at the horizontal illumination, and we require to adequately light a road layout. We're looking at 7.5 lux, or that's the units used to describe the level of illumination a light, how the brightness level of the light at the road on the approach to crossing. And you will use horizontal illumination only on the approach, because you're treating the approach to crossing just like a normal road layout. You're going to light it like a normal road. So we use category V lighting up to 7.5 lux. Category PX, on the other hand, is lighting at pedestrian crossings. You're looking at a minimum of 32 lux, because you want, at pedestrian crossings, you want the lighting levels to be bright enough to illuminate pedestrians at the crossing. You want drivers to be able to see a pedestrian. Same way at a railway crossing, you want drivers to be able to see a train approaching the crossing. So we looked at AS1158. We took the information and we developed the criteria for lighting at railway crossing. So that brings us to our next poll question, which is, do you think lighting is the only solution to reduce vehicle train crashes at night? You could raise your hand if you think that's false.
Alrighty, well, I'm just having a look at people's answers coming through, and we're looking about a 50-50 at this point, unless we've got some shy people that just haven't raised their hand. Most people have raised their hands, so false.
Yes. Thanks everyone for answering that question. Yes, you're right. The answer is false. Lighting is not the only solution, and the reason why, you have to look at it from an outside-in approach. You have to look at it from a holistic approach. Lighting is just one of the solutions to prevent crashes railway crossing at night. You have to evaluate all aspects of road safety at railway crossing. These are the areas that you need to look at. What are the causes of the crashes at night? You have to see why are there crashes occurring at railway crossing at night. It may be a illumination issue. It could be there could be a lack of signage. It could be a speeding issue. Is lighting the most feasible and practical? Lighting at railway crossings, there's a big cost involved, especially in rural areas where you need access to power. Is it the most feasible and most practical? Are there other measures? Can you consider other measures? Maybe you might consider warning signs, or maybe putting in a vehicle activated sign that is solar powered to warn motorists that a crossing is ahead. Or maybe it's a combination of other measures. Maybe it's a combination of vehicle activated sign plus lighting. So you got to firstly evaluate the crashes, see why the crash is occurring, and then look at the solutions. You have to look at the holistic approach, and then think, okay, I've looked at all the crashes, and it looks like it's a visibility issue at night. This area doesn't have much ambient light. Trains use the crossing quite often at night, and drivers have said that after a crash, when you interview the driver, they're saying, well, they can't see the crossing, or they can't locate the crossing, and they can't see a train at the crossing. So that's probably why you might think of implementing lighting, or you might even consider other measures to go with the lighting as well. So it's a big approach, and you should always look at it from outside in approach and see whether lighting will be the most feasible solution. So we're going to stop there for maybe a minute or so to see if there are any questions, and just answer any questions that you may have.
Yes, thanks Ganesh. Well, we did receive one a little bit earlier on from Edward. Thank you, Edward, for sending your question through. So with reference to lighting, of course, how would this form of treatment compare to that of grade separation at railway crossings in terms of treatment priority? Ganesh?
Yeah, well, grade separated, there is going to be a huge cost involved. Usually, obviously, if grade separated can be considered, that would be the best solution to separate the crossing from vehicle traffic so there's no interaction. But a lot of times, a lot of these crossings are located, some could be located in urban areas and some could be located in rural areas where there may be land take issues. So, and due to the main huge cost involved, it's always more appropriate to consider lighting or maybe even closing railway crossing rather than going down the grade separated route. So grade separated would be the ideal solution, but due to the cost involved, other solutions probably will take precedence before we go down the grade separated option.
Fair enough. Thanks
So
for
that
that,
answers the
Ganesh.
question. Yeah.
And look, we have another question from Carolyn. Thanks, Carolyn. She's asking, for the metropolitan active crossings, do you think that boom gates should be installed on both the approach and departure sides of the crossing to minimise metro crossing crashes?
Yes. We also did a research for RMS last year regarding boom gates crossing, and some of the crossings were either half or full crossings, and a lot of research showed that full crossings were always the most effective. That means you have the boom gates goes down and obstructs the departure side as well as the approach side to prevent drivers from going zigzagging across. So definitely boom gates in met areas, full length boom gates will be definitely be more beneficial than half length boom gates. Yeah.
All right, fantastic. Well, there's some great questions, and of course we encourage everyone else to get your questions through. At this point, Ganesh will be able to answer them afterwards, after he's finished his presentation. So thank you everyone for those questions, and Ganesh, I'll let you get back to it.
Yep. Next, we're going to look at the design considerations. What do you need to look at? There are 5 key areas that you need to look at before you start thinking about when you start planning lighting for railway crossings. First are the checklist, site selection criteria, design flowchart. Once you selected your sites, site selection criteria can help you prioritize your sites, choose which sites you're going to treat first. The flowchart will decide how you go about what kind of lighting you implement. The design objectives will help you focus your solutions. What are you trying to achieve by providing lighting at the crossing? And the design principle outlines the parameters that you need to look at, the various levels like the aluminums, lamp requirements, what type of lamp you're going to need, how you're going to treat glare, the parking issues for maintenance vehicles. You've got to look at the risk because now you're putting lighting columns in. What risks are they going to involve? You've got to look at those risks and then mitigate those measures. And then finally, once you've installed the lighting, you evaluate the effectiveness of the design and see how effective the designs of the lighting has been to reduce vehicle-train conflicts. Here I've prepared a site selection criteria that practitioners could use to prioritize the railway crossing sites in their jurisdictions to see which sites should they treat first. For example, if they have 10 sites, if they have a sum of money to treat 10 railway crossing sites, how are they going to go about prioritizing the sites? Or they have 10 sites and they want to see which sites warrants lighting. So these are the areas that you look at and questions that you should ask yourself. I probably won't go through each point because of time constraints, but if you have any questions, please feel free to ask me later. I'll just talk about rail and traffic volumes and a couple of the points. Rail and traffic volumes is quite important because if you look at the railway crossings, you might have some railway crossings that have maybe 1 or 2 trains at night. Some may have maybe 5, 6 trains at night. And you also have type of rail operations. If it's a passenger trail line, rail line, the risk level is a lot greater than maybe a freight trail line because of risk of derailment and injuries to passengers and so forth. So these are just some of these areas that you look at and ask yourself the questions before you decide which sites should take more priority than the other. And the design criteria for passive crossings. There are two flowcharts that I've prepared. These two flowcharts get practitioners to ask themselves the questions: what kind of lighting do they need on approach to the railway crossing, and at the railway crossing, at passive railway crossings? On the approach to passive railway crossing, if lighting is required, you will implement category V lighting. And at the railway crossing, if lighting is required, you will look at to implement category PX lighting. So this flowchart is also similar to the active railway crossing, but the only difference is at the active railway crossing, you don't need lighting. You just ask yourself the question if, based on site inspection and the site conditions, whether you need lighting. And if you need lighting at the active crossings, you install category PX lighting. So these two flowcharts for active and passive crossings lets the practitioner decide whether they need lighting, and if they do, what kind of lighting should they be implemented. The design principles that I've prepared is a list of things, areas that you should be include in your design, such as the number of spans of lighting that you need, the lamp type, vertical illumination, illuminance level, horizontal illumination, what kind of poles that you need, the pole setback. You got to make sure you maintain clear distances. The poles, in terms of a crash, poles could fall onto the tracks, so you got to make sure there's a minimum of 5 meters clear zone from the tracks. And you got to make sure that the lamp type that you use, as mentioned earlier, the most important point at lighting railway crossings is the difference in the color contrast. So if you're using high pressure sodium on the approach, you want to use something different at the crossing, something like metal halide, which has a white light. So that gives different color contrast. So these are the design principles that you look at once you've decided to implement lighting, what you need to implement. So we can stop there real quick if anybody has any questions on the design criteria. I know there's a lot of information there that we have to go through quite quickly, but if any questions, I'll be happy to answer them right now.
We have had a question, but unrelated to design, I'm afraid. I'd just like to let everyone know that we are in fact recording today's session, so everyone will have the opportunity to listen back or to review the presentation at a later date if you wish. But that's all we have at the moment, Ganesh, so back to you.
Okay. Yeah, thanks. As mentioned earlier in the design consideration, you need to look at risk. When you're putting lighting at railway crossing, the lighting columns, the lighting poles itself is a risk. You're going to have collisions with lighting pole. The lighting pole could fall onto the railway tracks. The glare could distract not only the driver, the vehicle driver approaching the tracks, the railway crossing, but also a train driver approaching the crossing. And there's also a risk of a difference in color contrast. If there's a lack of a difference, that a driver may just continue driving across. So you need to look at this risk and develop suitable mitigation measures. And some of the suitable mitigation measures could be putting in panels on the lamps to minimize the glare. Make sure you use different types of lighting. Make sure you use frangible columns so that there's reduce the level of injury to a driver in the event of a collision, and to ensure adequate clear zone distances are maintained from the road. And finally, once you've decided to implement lighting, you need to get the lighting design approved by the stakeholders. Some of the key stakeholders will be the railway authorities in Sydney, Sydney Trains, Transport for New South Wales, and also RMS. In Queensland, you may have to liaise with Queensland Rail, Victoria, Vic Roads, and also you might want to get the emergency services involved, the police, get their feedback. What do they think? What input could they provide? Ambulance services, because they might provide their input into lighting rail crossing. What kind of lighting do they want? Do they need? And and get their feedback and get their input into the designs. These are just some of the different types of lighting layouts that you could consider. The two different types of approaches are a straight approach and a curve approach. And at a passive crossing, you want to light the approach as well as the crossing itself. And on an active crossing, you look at only lighting the approaches, and you only consider lighting the crossing itself if there are any dark spots or it might enhance the road safety of the crossing by providing lighting at an active crossing. On a curve approach, where there's a higher risk of loss of control incidents by drivers approaching the crossing due to lack of visibility or inappropriate speed because they do not appreciate the road alignment. So in the same way as a passive crossing, as a straight approach of passive crossing, you would illuminate the road layout so that drivers have a better appreciation of the road layout. They can visualize the curves in the road, as well as you will illuminate the railway crossing at a passive approach, passive crossing. On an active crossing, on a curve approach, you would just illuminate the road layout so that drivers have better appreciation of the road alignment. But at the crossing itself, at the active crossing, you will consider lighting based on site conditions. So these are the different types of lighting layouts. This is not comprehensive. It's just an example to give you something to think about. And I'm sure based on in your jurisdictions, based on your different road layouts, you may consider using this as a guide to help you just start and think about the different types of lighting designs that you could implement. And here in New South Wales, ARB assisted the RMS to develop this guideline, the guideline lighting railway crossings. This guideline, the input from our research, ARB research, was taken on board, and RMS developed the guideline. The guideline was published in May 2013, and the aim of the guideline is to give practitioners with a standard tool to provide advice, to provide guidelines on how to go about implementing lighting, how about go about designing lighting. It's to help practitioners have a level of consistency throughout the states, so they have a common framework that they could use. Currently, there's no framework. They may use different lighting guidelines that rail authorities use their own different guidelines as well. So I'll just show you roughly what the guideline looks like. Firstly, where you could access the guideline. You just go down to the RMS website at the documents section, and you just click on railway guidelines, and it comes up with the lighting railway guidelines document. And just looking at the table of contents, it gives you all the information that we went through in the webinar today is presented in the guideline. And it also has in the appendix various checklists that you could look at to help you in your design. It gives you different questions that you should ask for the different risk, what you could look at, and so forth. This will help the practitioner with just a level of guidance on what they should look at and how to implement lighting. Even if you're not from New South Wales, this guideline can just help you think about, can just help you along, give you the guidance on implementing lighting at in your jurisdiction. So we've come towards the end of our presentation. I just a few more slides just to summarize the information presented. The main aim of lighting railway crossings is to reduce crashes at night. The aim is from a road user perspective, road safety perspective. It's to help improve road safety for drivers approaching the crossing as well as other road users. The key concepts introduced at lighting for railway crossings are 4 main concepts: horizontal illumination, category V lighting that is implemented on approach to the crossing, and vertical illumination, category PX lighting at the railway crossing to illuminate the crossing itself and the sides of the train. And it can be shown that lighting at railway crossings, even though the risk may be low due to the low number of trains at low level of crashes over annually, but the consequences are quite severe. So lighting at railway crossings can improve road safety. And the key point that you should note is there needs to be a clear difference in lighting contrast to give drivers a chance to appreciate that there is a difference that in the road, there's something in the road ahead, there's a process, the hazard in the road ahead, to give them a chance to identify the crossing. Introduce the New South Wales Lighting for Railway Crossing Guideline. It was developed with research from ARB, and it helps create a level of consistency. It helps to allow practitioners to develop consistent design and implementation of lighting at railway crossings in New South Wales. And hopefully this guide, practitioners from interstate will be able to use this guide in their jurisdictions and help perhaps develop something similar along the lines for use within their jurisdictions. So I hope everyone enjoyed that webinar and took a lot of good knowledge on board, and I hope you found the webinar extremely useful and will be able to take away what you learned today and apply it to your future projects. Thank you for your attention, and ready for any questions that you may have today.
Great. Thank you so much.
Questions?
Thank you so much, Ganesh. That was fantastic. We have had a couple of questions, so I'll just run those past you. Question from Jeff. Jeff wants to know, does the guideline have information on how you start to engage relevant stakeholders into a conversation about implementing some lighting to a railway crossing?
Unfortunately, the guideline doesn't give you any guidance on that. The guideline just states that any lighting proposals should be, relevant authorities should be consulted before implementing. So with lighting railway crossings tend to be maintained by the railway authority, could be Queensland Rail or Sydney Trains, and the road layout is under the road authority jurisdiction. So in New South Wales, that would be RMS. So if a jurisdiction wants to implement lighting, they need to consult both the RMS and the relevant railway authority, would be Sydney Trains. So it'd be beneficial right from the onset, once you've decided that if you're going to select A, B, C sites for implementation, you get the stakeholders on board as early as possible so that you can engage their input and design accordingly so that it prevents problems much later on.
Wonderful. Okay, not a problem. Another question from Martin. Martin is asking if there is a similar Vic Roads guide that can be applied to Victoria, or should we base designs on the New South Wales guide? And I guess those in the other states as well would be probably having that same question running through their minds. So what are your thoughts on that, Ganesh?
Well, our thoughts were, well, when we developed this research, we didn't specifically come up with anything new that is really not out there. All the concepts that we raised, all the horizontal, vertical illumination, category V, PX lighting, were all obtained from the standards, the Australian standards, which is applicable for use throughout Australia. So anything that was presented in the New South Wales guideline can be applied in other jurisdictions. So it's not exclusively for use that in New South Wales, they can't be applied in Victoria. The lighting principles on their own can be applied anywhere in Australia. So I mean, from my point of view, it can be applied anywhere in Australia.
Wonderful. Well, that's great news. Thank you, Martin. I hope we've answered your question there. But of course, you can always get in touch with Ganesh after the webinar if you'd like to chat about that a little bit further. And just on a final note, we have a question from Carolyn come through. I might just make this the last one for today. Any further questions can, of course, be sent either via email or telephone to Ganesh afterwards, and you can catch up with him on any unanswered questions. But Caroline would like to know if there is a copy of the Boomgate research paper produced by ARB available for review. Ganesh.
We probably have to consult the RMS before we release the paper, because it was presented as a paper to RMS, and we probably need to consult them before we can release it. So I can get back to you on that. Yeah.
That would be great. Thank you, Carolyn. We've recorded that question, and we'll look into that for you and hopefully come back with an answer very soon. Ganesh, thank you so much for your time. I really appreciate you taking the time to deliver this webinar today. I personally found it really enjoyable, and I've learned a thing or two about railway crossings myself. So there you go. And as I've mentioned, we are recording today's webinar. That will be made available. All of the presentation material will also be sent to all our attendees here today. We hope that you can join us again in future, and thank you all for your attendance today. So on that note, I will bid you all goodbye and hope you can join us next time. Thanks.
Thank you.